My name is Motsamai. I teach here at Kofifontein Guided. I'll be taking you through the grade 10 memo discussion. That ends here. I don't know if you can hear me, leadership. I think we can start. That ends here. Colleagues, can you hear me? Can you please give me an indication if you can hear me, because I'm not sure if I'm audible on your side.
We can hear you, Dade. We can hear you, Mani.
Dr. Motsamai?
Okay, no, thank you. Thank you, leadership. That
You
ends here.
can
we
hear me,
start?
Dr. Motsamai?
Yes, I can hear you now.
You know, the problem is one. I'm having a challenge with the other mic, ne? And I hope it's not going to make an echo, but let's try. Ne?
Okay.
Okay. Let me just welcome the colleagues and maybe just give them the logistics that will follow.
Okay.
Colleagues, good morning and welcome to this grade 10 marking guideline standardization meeting. And I hope all is well and we are doing the best out of the situations that we are faced with, that all the papers are very close together and marking it is taking a bit of a problem. But it is something that we have to go with, and then we'll see how best we can do about it. Let me wish Ntate Motsamai the best of luck the presentation and welcome everyone who is in this meeting, and then we'll appreciate it if you can also make a lot of contributions towards the standardization meeting, so that at least we will be having a solid and a lot of maybe inputs pertaining to the standardization, especially on the alternatives that we might have. So without much ado, I see now we're having about 34 people in the, but they are going to be of great help to us. And Dr. Motsamai, let's start. Time is not on our side.
Okay, leadership. No, thank you.
Thank you, Bob.
Thank you, sir. Good morning, colleagues, once more. We noted a few changes, but particularly for Afrikaans paper. I'm sure in the memorandum that was sent or shared with you, you noted there were options there that indicated to say for Afrikaans learners only. And those were because of the translation that took place. Some of the values there were changed. As a result of that, we had to amend the marking guideline to suit also the learners in Afrikaans. Without wasting time, I have not received any inputs when it comes to multiple choice. Question 1, so far I have not seen any input, so I would love to believe that for question 1, the options will remain as they are. Question 1 up until 1.10, there were no inputs, unless there are inputs now in this meeting. But so far, I did not receive any inputs with regard to question 1. That ends here.
On my side, Dr. Motsamai, there is nothing. We can continue to question number 2, Bob.
Okay, thank you. In question 2, it says, the diagram below represents a wave moving from left to right. The time between the two consecutive throats is 2 seconds. 2.1.1 define the term frequency. For 2 marks, it was defined as the number of wave pulses per second for 2 marks, or the number of successive crests or troughs passing a given point in a second, or per second rather, for 2 marks. That will be 2 or 0. That means it's not part marking. Question 2.1.2 says calculate the amplitude of the wave, and it is calculated as 1.25 meters. That means they just divided the 2.5 meters there by 2. And then question 2.1.3 says calculate the wavelength for 2 marks. And in calculating the wavelength, that was given as 7.5 meters. And that's 2 marks, to say that they've divided their 15 meters by 2, because we have 2 complete waves here. And then question 2.1.4 says calculate the frequency. And in order to calculate the frequency, option 1 said they use the formula frequency is equal to 1 over period, which is 1 over 2, or 0.5 hertz. That would be for 3 marks. If they took the longer option, then they would have calculated the speed of the wave. That is this will be from question, it's CA from question 2.1.3, where they are given the wavelength divided by time, and then they use that speed to calculate the frequency there. But marks are only allocated for the formula, correct substitution, and then giving frequency as 0.5 hertz. That would be question 2.1.4. For question 2.1.5, it says calculate the speed of the wave, and the speed of the wave will then be calculated to say it's V is equal to frequency over lambda, times lambda rather. And then this is also CA from question 2.1.4, where the frequency there will be 0.5 multiplied by the wavelength, which is also from question 2.1.3. And then that will give you the speed of the wave as 3.75 meters per second. Or alternatively, they can use the speed formula, which says V is equals to change in position over time, and that's the wavelength divided by time, which is 2 seconds, and that would give you 3.75 meters per second. That would be question 2.1.5. And then in question 2.2, it says a sound emitting device is placed between 2 buildings, A and B, as shown below. The distance from the device to the building A is 343 meters. The sound wave strikes building B perpendicularly and returns to the device after 3 seconds. They say the speed of sound in the air is 330 meters per second. Calculate the distance delta x between the 2 buildings A and B. And for that, use 4 marks. It says the distance from the device to building B, that is that's displacement or change in position, is equal to V times time. So 1 mark for the formula, the speed of sound in the air multiplied by time it took to get to the building, and that will give you 495 meters. And then the total distance between the 2 buildings, that is from A to B, that's the distance from A and plus the distance from B, and that gives you 838 meters for another mark. So it's 1 mark for the correct formula, 1 mark for correct substitution into the formula, 1 mark for the sum of the 2 distances, and 1 mark for the answer. That is 4 marks, and for a grand total of 15 marks. That is question 2. That ends here.
Thank you, Motsamai. Just one input that I want to make everybody at this point. Question 2 and 4 as an alternative for calculating that frequency. Yes.
Okay.
That's another option. Being frequency equaling to number of waves divided by the time. So for one wave, we are given the time of 2 seconds. So it is going to be one wave divided by 2, and then it is going to go back to that 0.5 hertz.
Okay.
Yeah, I think that is another option that we have. And then I don't see anything on the chart or any hand. So meaning that we can proceed to question number 3.
Okay, sir. Thank you. In question 3, it says radio waves have a wavelength of 0.15 meters. And then 3.1.1, give one use of radio waves in technology for 1 mark. And the options that are provided is radio and TV broadcast, communication, locating information about our universe. So any of those options, only one option is required. And then question 3.1.2 says calculate the energy of a photon of these radio waves. And the option that is provided there is the equation or the formula that says E energy is equals to Planck's constant times frequency, or Planck's constant times the speed of light divided by lambda. Any of the two formulas will award a mark there. And then 1 mark will be awarded for correct substitution into the formula. That is Planck's constant times speed of light divided by the wavelength of that wave, which was 0.15 meters. And then 1 mark for that correct substitution. And then 1 mark will be provided for the final answer there, saying that energy of a photon is 1.326 times 10 to the power negative 24 joules. That is question 3.1.2. For question 3.2, X-rays emitted by the X-ray machine have a frequency of 2 times 10 to the power 19 hertz. 3.2.1, calculate the wavelength. And you calculated the wavelength by saying the speed of light is equal to wavelength times frequency. So the speed of light is 3 times 10 to the power 8. Correct substitution there. Multiply by the frequency, which is 2 times 10 to the power 19. And your answer for wavelength will be 1.5 times 10 to the power negative 11 meters. Option 2, it says energy is equal to Planck's constant times frequency. Then we award a mark for correct substitution of the formula there. Then you take 1.326 times 10 to the power negative 24 is equal to Planck's constant multiplied by speed of light divided by lambda there, and you get lambda as 1.5 times 10 to the power negative 11 meters. That is question 3.2.1. And then question 3.2.2 says explain why X-rays have a high penetrating ability. And the answer to that is it has a high frequency, that's 1 mark. Another mark would be for high energy. That's the type of electromagnetic wave. It has high frequency, therefore high energy. And that will be a total for question 3 of 9 marks. That ends here.
Thank you, Ntate. We are having 2. One, it is from Mr. Tunzi, and then the other one is from Jordan. Can you start with Ntate Tunzi for 2.2?
Okay.
And if you also Ntate Motsamai is to just zoom a bit.
Zoom out.
See, yeah, just a bit.
Okay.
Again, just a bit.
Sharp.
All right, that's fine. I think it's fine. Okay. Tunzi, can we hear from you? Mr. Tekiso? Okay.
Yeah,
Let's go to Jordan. Okay.
Okay. Ntate
Go
Ntsiya?
on, but
Hello, Ntate Ntsiya? Ntate Motsamai?
go on.
Okay,
All
Mene,
right, okay. Yes, thank you. Ne ke re fela ke kopa tle re hlokomele on question 2. I couldn't speak on the other time. Michael needs to do this. And then first, re ke ka leka this question number 3. On the option ena ya go etela, there were swapped values, so I think I might have missed it. We've spoken about it. So there are values 2 multiplied by 10 to the power 19 was swapped 4, 3, 2, 1.
This one.
Yes, 3, 2, 1. So the values were swapped. The answer that is there is 1,5. Yes, yeah, this is fine. No, thank you, Kalebo. And then now just maybe for question number 2 as well. 2.2, I suggest perhaps we can also consider.
We are missing you.
Oh, okay. All right. I was saying for question 2.2, I was saying perhaps we can also consider the formula that one, the speed is equals to distance over time there, because probably at this time, well, at that time when they were learning, they were using that equals to distance over time, just as a consideration in that.
But that
Okay.
the formula must be
Written
the way it appears on the question paper.
Yeah, I think it's one other issue that we need to address.
Yeah.
But for teachers, as this is a marking guideline, not a teaching guideline, they must understand that it is not a formula. It was just something that you developed.
Mm-hmm.
Okay. Yeah. Can we take Ms. Jordan? Are you okay, Ms. Jordan? Okay. In the absence of any, can we take Ms. Halo?
Thank you, Daddy. I want to refer back to 2.2. Multiplied the speed with 3, then later on divides that 990 by 2 to say, where can I allocate a mark? Instead of the learner using the half time, that 1.5, yeah. So I kere ngwana wa bona hore that distance o tlo divide ka 2 e kgone mo fa the same 495. So where do I place my mark? At the division part or at the substitution part?
We are on question 2.2, ne? And then you said ngwana o tsile
Ngwana unkile instead of us sebedise 3 ne? Instead of us we say 1.5, so we say 3.
Okay.
Using the total time. Then total distance we are looking. Then afterwards, it's only then that the learner divides that 990 by 2, which will still be 495.
Okay.
And then adds.
Then add the two distances.
My concern is, where do I give a mark for substitution at that point?
I think that the first one would be the use of that formula. They used the formula of distance is equal to speed times time. So they are going to get a mark for that.
And substitution.
And substitution there, they will also get that mark. The only difference is that instead of saying 495, they would have a different 990, which then they divided by 2, obviously, to get 495. So they still are going to add the 2. So if they added the 2, they will still get that 1 mark and get the 1 mark for the answer.
Okay, leadership. If ngwana asa divide ka 2, ke tlo mo fa mark wa adding mara ke. Ona le 990 plus 343. I agree. Manko o tlase mo is for adding. Meaning can I positive within the question?
Yeah, it should be like that, but I'm not sure. That is the only advice. Can we say we have in question positive marking?
Yeah, got 2.2.
Yes.
Because that mark is for adding.
Yeah, for the sum
mark
of the
number
two.
3. Yes.
Realizing that they need to add the two distances.
Okay. No.
But they will forfeit that one.
Forfeit the final answer. For 2.1.4, I think maybe we should also note positive marking, especially higher option 2. I think it's not noted. 2.1.4.
I actually saw that. I said it earlier that it will be included there to say this is positive marking from the previous two questions, because 2.1.2 and 2.1.3 influence the answers of 2.14 and 15.
Okay.
So it will just be added there on the memo, updated memo. Tatensi, are you still with us?
Thank you.
Thank you, ma'am. Looks like Tatensi. Okay, Tatensi looks like Tatensi is unavailable. Menteo.
Thank you, Motsamai. Ke kopa fela 311. If ngwana as mentioned as a broadcast part, it's a TV or radio. That is my first question. My second one is 322. With the formula E is equals to HF, E is also equals to HC over lambda. So if Elena mentioned high frequency, but about low wavelength, kappa shorter wavelength, then what do we do? And the last one, ke taba yane ya 215. That didn't see we should not take speed is equals to distance over time. Or ona our teaching. Thank you so much, Ntate Motsamai.
Okay. Menteo, for TV and radio, it's not necessary for not web broadcast, so it's fine. It's just they said uses. So it's been used in radio, it's been used on TV. So it's just fine if they just hold one of the two, radio or television. And then to answer your next question, I think you said something here. Was it on 312?
322.
322. Yeah. So I'll do the opposite to say if it will have low wavelength, right? Am I understanding you well?
It will have high frequency and low wavelength. So instead of mentioning energy, the learner mentioned.
They just spoke about the relationship between frequency and wavelength.
Yeah.
It's a bit tricky that way. And Tatensi, please come in. But I don't think we will have to penalize the learner for that. For me, I would say we award a mark if they did not indicate the question of NH. But I'll take it. I'll take it under advisory, and then it will be updated.
Let's take Malasela and just show us the question.
The question was here that explain why X-rays have a high penetrating ability.
Yeah, once you talk about that question basically is asking about the energy. Can only go in there when it is having a high penetration energy, because we cannot still talking about the energy, cannot talk about the relationship about what is happening with the wavelength. That is basically, that's why some of these radiations, they don't even penetrate, and they are not causing something like bone cancer, something like that. Is fairly based on the penetration that it is causing death to some other cells. So it has to do with energy and not any other way. Yeah.
So that means we it remains like that. We award for energy, and also if they made mention of that high frequency or low wavelength.
Let's give it. Fine.
Okay. We take a Memo after.
Memo Lashala, yes, yeah.
Good morning, colleagues. Mine is on 321. I just want to check on option 2. That second mark, is it for only the right-hand side of the calculation or everything? Because when I look at that, the line below the HC over lambda, it is only on the right-hand side.
It is for both. Correct substitution. It will be for correct substitution there. I think it will just need to be edited out. But it should be for both right and left.
Thank you.
Sorry, Tatensie. The other thing, I humbly request colleagues to write their options down and then send them to their respective subject advisor so that when Tate updates the memo, he doesn't have to think hore motho o reng ngwana o ngotse jwang. Thank you.
Well taken, Mayor.
Thank you, ma'am.
Thank you. Colleague, sorry, I was out for a minute in a meeting, but I think we resolved that other question. Thank you. And we can proceed.
Okay. We are now in question 4.
Before we proceed, I see a hand. Tatemo happy?
Yes, Minister. Thank you very much. I was saying that please check on the chat. Some colleagues are writing their questions on the chat there. Can you please attend to them?
The first one, I think we addressed it. The second one was from Tate, or is it Me? It says, we'd like to suggest that we consider either a high frequency or high energy, and then state that they are directly proportional to penetrating ability, as the question was about penetrating ability. I think that's also what we have addressed. Yeah?
Yes, Baba, that's what we're talking about. Yeah.
Unless Marlene wants to come in.
Good morning, sir.
Morning.
I just would like to ask, I understand the question on 3.2.2, and that is fine, but I would just like to ask on the option 2 of question 3.2.1. We use there the energy from question 3.1.2, but I do not feel that we can use that, as question 3.1 was referring to radio waves and that energy, where in 3.2 we are referring to X-rays. I do not think that is a valid option using that energy that we calculated in 3.2.1. 3.1.2, apologies.
3.1.2. Yeah, I actually thought of that as well, to say it does not show that there is a correlation between the two for us to take it as an option. I don't know, do you understand what Memo is saying?
Yes, I do understand that we are looking at two different frequencies, and then you cannot apply one on the other.
Yeah.
Which is a valid point that we shouldn't take. And so that option number 2, I think we need to re-look at it, and then if possible, not discontinue it in the marking guideline.
Yeah, I also feel like that. We'll look into it. Thank you, ma'am. Thank you very much for your input. That Sibinda. Can you unmute, or are you sorted? Because I see your comment there on the chat. Okay.
Let's take Meskhalo on that.
Meskhalo?
Okay, colleagues, I'm saying on that issue of 3.2.1, when you multiply Planck's constant with the given frequency, it gives the same energy as the one above. So it's not an issue of positive marking per se.
Oh,
Yes, when you multiply that with the given frequency, it works out to that energy. It works out to 1,326 times 10 to the power of negative 14. It's just a coincidence.
Or it was just a fortunate coincidence that the
Yes,
answers
when
are
you
the same.
when you multiply Planck's constant with that frequency, it gives you that energy which is similar to 312. So that option is still correct.
Oh,
But
no,
now
thank you.
the exponent, as I don't have a calculator near me.
Oh yes, the
saying-
above one exponent ke yeah energy ne I say power 20 I say power 24 ke power negative 14.
Yeah, now that will make a difference.
Yes. It shouldn't be 2 to the power of negative 24, but to the power of negative 14.
Correct. 3.2.1. Are we fine, Tadenzi? Can we move?
I don't see anything on the chart, and on I think we can proceed. We'll look into that option number 2, and then on the updated Memo, I think we'll do it.
Okay. No, thank you, leadership. Colleagues, we are now on question 4. This is where I highlighted that there was a challenge with in Afrikaans paper. So this is where that challenge appeared. It says sphere A carries a charge of negative 2 times 10 to the power negative 9. That mean I'm on a memo discussion. Can I call you back? Okay, Minia. Sorry, colleagues. Times 10 to the power negative 9 coulombs, while the charge on sphere B is unknown. The spheres are brought into contact and the charge on each sphere is 1,5 times 10 to the power negative 9 coulombs. 4.1 says state the principle of conservation of charge. And the principle of conservation of charge is defined as the total charge of an isolated system remains constant during any physical process. So that is true or nothing. If we move on, it says question 4.2, calculate the magnitude of the unknown charge on sphere B. And the option that was provided there was to use this formula that says new charge, which was already given, is equal to charge 1 plus charge 2 divided by 2. And the new charge there, you award a mark for substituting that new charge. You award a mark there for substituting on the right-hand side of the formula. And then you get a mark of 5 for the answer that says 5 times 10 to the power negative 9 coulombs for charge B. For Afrikaans learners, because of theirs, it said instead of negative 9, that they said negative 6. So they will also get a mark for correct substitution there. They will get a mark for that substitution on the right-hand side as well. And then they will lastly get a mark for the final answer. But their final answer will be 5 times 10 to the power negative 6 coulombs, as opposed to the English learners that have 5 times 10 to the power of negative 9 coulombs. That is for 3 marks. And then question 4.3 said, show by means of calculation that the number of electrons transferred during contact is 4,74 times 10 to the power 10 electrons. And for option 1 says, learners would calculate the change in charge there, and they get their change in charge as 3,5 times 10 to the power negative 9. And then they use the formula that says number of electrons is equal to charge divided by elementary charge, which the change in charge would be substituted with the charge of an elementary electron, which is 1,6 times 10 to the power negative 19, and then you'll get a mark there. Now, what we need to note is that marks are allocated for calculating the change in charge, which is 1 mark, substituting for correct formula and substituting into the correct formula. We are not awarding mark for number of electrons. The second option will also be likewise if learners calculated the change in charge using charge B, which is from question 4.2. If they substituted, that will be positive marking from question 4.2 there, and they get their answer as well as 4,74 times 10 to the power 10 electrons. But we award mark for the path, meaning the change in charge, the formula used, and correct substitution. I hope that is clear, colleagues. And then for Afrikaans option, that is based on the fact that they used macro, not nano. Then they will calculate their change in charge and get it as 3,5 times 10 to the power -6. Substitute into the correct formula there, and they will get their number of electrons as 2,1875. But since we are not awarding mark for that, it will not pose a challenge. We are just awarding marks for the path that learners took. That would be question 4 for 8 marks. Thank you, sir.
Thank you, sir. Colleagues, I see some hands. This thing is kicking me out, in and out. I don't know what is happening. Can you take it from your side? That okay?
Yeah.
No, it's fine now. I see Marlene.
Marlene, we can unmute.
Good morning, sir. I'm at question 4.3. On the question paper as well as on the memo, I do not agree with that 4,74 for the English that was calculated. According to my calculation, it is 2,1875 times 10 to the power 10. And that was a mistake that was in the paper and then also reflected in the memo as well.
This one?
Yes, sir.
Okay. Let me see, 3,5 exponent -9 divided by 1,6 exponent -19. Oh, it's the same. Yes, it's 2,1875 times 10 to the power 10.
Yes, sir. I would like to ask or request there on behalf of the learners, because there was a question that we raised on Friday as well to our leadership to ask how, because of the change and the mistake that we noticed, that we consider please marking and awarding a mark for the electrons calculated and rather do a shift in marks from question 4 and question 5 as the learners, they needed to calculate that actual value.
Okay, ma'am. No, I hear you. I will talk to Mr. Nzie, and I think it will be indicated on the updated memo.
Thank you, sir. I appreciate it.
Thank you, ma'am.
Yeah, I think it will be in order, that ma'am.
Okay. I don't see any other hand here. All the hands.
Yeah, and also on the chat, I don't see anything, Baba.
Okay, sir. I think we can move.
Move on, Baba.
Thank you, sir. Colleagues, we are now on question 5. For question 5, it says 3 resistors, R1, R2, and R3 are connected to a battery as shown in the diagram below. Resistor R2 has a resistance of 2 ohms. The ammeter reading on A1 and A2 are 3A and 1A respectively. The resistance of the connecting wires and the battery can be ignored. Question 5.1 says define the term current. And current is defined as the rate flow of charge for 2 marks. That's 2 or nothing. And then 5.2 says calculate the potential difference of resistor R2, the potential difference of the resistor that is connected in parallel. And there is a total current that's the current passing on both of them, will be R1 plus R2, which gives us the current passing on R2 as 2 amperes. And then we use that current that is passing on R2 to calculate the potential difference across R2, where it says R is equals to V over I, Ohm's law. And then we substitute the 2 ohm resistance and also 2 amperes for current. And then the final answer will be 4 volts. So that will be for a total of 5 marks. 1 mark is for that sum there. 1 mark is allocated for the current in R2. And then 1 mark is for the formula. Another mark for correct substitution into that formula. And then lastly, it will be for the answer of 4 volts. If we move and look at question 5.3, it says calculate the resistance of the unknown resistor R3 for 3 marks. And then if you look at 5.3, it says positive marking from question 5.2, and you get that this potential difference across the series connection would be equal to the EMF of the battery minus the potential difference across parallel connection, which will be 8 volts. And then we award a mark for substitution, and then we award a mark for calculating that resistance there. That will be correct substitution and resistance. We have already awarded a mark for that formula before. And then it says, how does the resistance of R1 compare to that of R2? Right, higher than, lower than, or the same as? Explain the answer. And it is higher than. Reason being, R1 has lower current than R2. Therefore, R1 will have a higher resistance than R2. So that would be for 2 marks. That's question 5.4. And then lastly, calculate the energy transferred to resistor R2 when 3 coulombs of charge goes through it. And then for 3 marks, 5.5, it says the correct formula, that's V is equals to energy divided by charge. And then correct substitution into the formula. And lastly, for getting energy as 12 joules for 3 marks. That will be question 5 for 15 marks. That ends here.
Thank you, Baba. Can you take Marlene?
Good morning, sir. It's me again. I would just like to bring something under your attention. Question 5.1, where we asked the definition for current, is also a question that repeated in the multiple choice. And I just think that it might be something to consider in future, as if the learners did not know the answer, they are being penalized twice for the same question.
Okay, no, thank you, ma'am. Thank you for the input. I think the internal moderator is listening.
Thank you, Tatensie. Good morning, colleagues.
Morning, sir.
I just want to check Motsamai on 5.3.
Yeah,
if a learner did not show the difference, 12 volts minus 4 volts to get 8 volts, but then the learner uses it there on the substitution as 8 and not either 12 or 4. And can we award the second mark there?
Who I believe we should. We are awarding a mark most for the answer, not the difference there. For potential difference on series connection. So for them knowing that the potential difference is 8 volts, they must get a mark for that. And then they will also get a mark for correct substitution. So the child would get full marks.
Okay.
Yes.
No, thanks, my dear.
Thank you.
Okay. Ntateduru and colleagues, you must also take cognizance of what you are writing as instructions in the question paper, because we are saying learners must show all the calculation steps. So be careful about that, because it was another thing that we are taking from DBE memo discussion, that they were very particular about what we are writing on the
on your answer sheet.
instructions.
Okay.
So for now, we are going to take it, but please, colleagues, be careful of such things, because learners in future will lose marks. Okay. There is a hand again, or is the elementary hand?
I think it's the old one, ancestor.
Okay, all right. Now let's proceed.
No, thank you, leadership. I think we are moving nicely. We are now in question 6. And question 6 says, a box which is on a smooth surface starts moving when 3 forces F1, F2, and F3 act on it as shown in the diagram below. And then 6.1 says, define the term resultant force. And the term resultant force is a single force that has the same effect as 2 or more forces acting together, or the sum of 2 or more forces acting together for 2 marks. It's also not part marking. And then question 6.2 says, calculate the magnitude and direction of the resultant force acting on the box. Magnitude and direction of the resultant force. The net force will be the sum of the 3 forces, that's F1 with 30, F2 with 120, and F3 with negative 80, acting in the opposite direction, and the net will be equal to 70 to the right. They must indicate direction. So 1 mark for the sum there, another mark for the magnitude of the net force, and 1 mark for the direction of that net force. And that is question 6 for 5 marks. That ends here. We have hands maybe, or comments. Okay. And that ends here. I think we are sorted with question 5. So I can move.
Question 6 actually. We are okay. Let's move on.
Let's move. Question 7 then says, a ball is thrown vertically upwards from the top edge of a 22.2 meter tall building. The ball reaches a maximum height at B, which is 2.5 meters from the point where it was thrown, as illustrated below. The ball falls and reaches the ground at point C. The motion from A to C takes 3 seconds. Ignore the effects of air resistance. And then 7.1 said define the term distance. And on the memo, the distance is defined as the total length of the path taken. And then 7.2 said determine the total distance of the ball from the moment it is thrown at point A until it reaches the ground at point C. We were to calculate the total distance of the ball, and the total distance there would be distance from A to B going up and coming back, plus the total distance of the building, and that will give you 27.2 meters. So 1 mark for the sum of the distances, and then 1 mark for the final answer. And then 7.3 said determine the displacement of the ball from the moment it is thrown at point A until it reaches the ground. Here they are looking for displacement. That's the change in position, and it is given as 22.2 meters downwards. So that will be 1 mark for the displacement and 1 mark for direction. And then 7.4, calculate the average velocity of the ball throughout its entire motion for 3 marks. And the velocity of the ball, we have positive marking here from question 7.3, which says average velocity is equal to change in position over change in time. And that is 22.2 meters divided by the time it took for the ball to reach the ground, which was 3 seconds. And the velocity was 7.4 meters per second downwards. So 1 mark for the formula, 1 mark for correct substitution into that formula, and 1 mark for the answer with direction. Answer with direction for 1 mark as well. That would be a total of 9 marks for question 7. That ends here.
Thank you, Ntate Motsamai. I don't see anything. So we are matching well. Unless if maybe I don't see. Really, I don't see. So let's proceed back.
Okay. Yeah, I also don't see nothing on my side. And then question 8. Question 8 says the velocity time graph below represents the motion of an electric toy car over a period of 24 seconds. The car initially travels north. Now, 8.1.1 says describe the motion of the electric toy car during the first 6 seconds. And the motion of the toy car is described to say the velocity of the toy car uniformly increased from 0 to 20 meters per second going north in 6 seconds at a constant acceleration. So 1 mark for indicating that the toy car was accelerating for that motion, and that also velocity has changed or was increasing from 0 to 20 meters per second. Direction is not necessary. It's not necessarily needed for this answer. So you will not penalize learners for not indicating the direction, but we do award a mark if they did not indicate direction as well. It says calculate the total displacement of the car during the first 12 seconds of its motion without using equations of motion. So here they require that learners use other ways, and the other ways to calculate area underneath the graph. And you have 2 shapes there if you look at that. It's for the first 12 seconds there we have a rectangle and also a triangle there. So that's area of a rectangle plus the area of a triangle. 1 mark for each correct substitution there, and then 1 mark for the answer and 1 mark for direction. So it will be a total of 4 marks for 8.1.2. And then if we go to question 8.2, it says a traffic officer travels at the speed of 12 meters per second when a biker passes him with a constant speed of 22 meters per second. The moment when the biker passes him, the traffic officer then accelerates his car at 3 meters per second squared for 4 seconds. And then it says define the term acceleration. And acceleration is defined as the rate of change of velocity for 2 marks. It's 2 or 0, there's no part mark in there. And then for 8.2.2, it says, by means of calculation, determine whether the traffic officer will reach the biker in 4 seconds. That is for 5 marks. And the answer there says, in the memo, distance covered by the biker in 4 seconds. The biker would have covered a distance of, because they're moving at a constant speed of 22, and in 4 seconds, then they would have covered a distance of 88 meters. And then for the distance covered by the police car, we can use the equation of motions, and there you have a formula, and then correct substitution into the formula to calculate the distance or displacement covered by the police car in the very same time interval. And you can see that you would have covered the distance of 100 meters. That is option A if we use that formula there. Or we can use option 2, And option 2, there's a distance covered by the car in 4 seconds. And you can see that we have multiple options there. If you look for first the speed or the final velocity of the police car after accelerating, and then use that to calculate displacement, how far the car would be when you have final velocity, and that will also give you the same thing. So we get 2 marks from that there. And then lastly, you have the learner has to indicate that the police car or the traffic officer would reach the biker in less than 4 seconds because he would cover a greater distance compared to the biker. So there, to show that the displacement of the car and displacement of the biker of the car would be higher than the displacement of the biker, which therefore says that the police officer will reach the biker in less than 4 seconds. So that will be for 5 marks. Please take note, 1 mark is for that conclusion there. 1 mark is for comparing the two distances to indicate that the car has a higher displacement than the biker. And also 1 mark will be for calculating the distance of the car, which is displaced, the formula and correct substitution for the traffic officer car. And also 1 mark will be given there for calculating the distance of the motorbike. Just the substitution, not the formula there. And then that will be question 8 for a total of 13 marks. That ends here.
Thank you, Dr. Motsamai. And on my side, I don't see anything really, which is unusual for the last 2 questions. It is just usual. So let's proceed, Bob.
Okay, thank you, sir. We are now on the last question. Last question is question 9. It says, a 4 kg block is released from rest at point A, which is 6 meters above ground. The block slides down to point B on an inclined surface as shown in the diagram below. Ignore the effects of friction. 9.1, says state the principle of conservation of mechanical energy. And on the memo, it's defined there as the total mechanical energy in an isolated system is conserved for 2 marks. And then 9.2, use energy principles to calculate the magnitude of the velocity of the block at point B. And the magnitude of the velocity of the block there, learners had to use the conservation of mechanical energy, meaning mechanical energy at the top will be equal to mechanical energy at the bottom there. And then you get 1 mark for that formula. 1 mark will be for correct substitution. That will be for mechanical energy at the top, that is potential energy at point A. And then 1 mark there will be for mechanical energy or kinetic energy at point B, correct substitution into that as well. And then lastly, that will be V is equals to 10,84 meters per second for a total of 4 marks. So 1 mark for the formula, 1 mark for calculating potential energy at the top, and 1 mark for calculating mechanical energy at the bottom. That will be for the whole thing there. That is kinetic energy, particularly at the bottom there. And then 1 mark will be for the answer, for a total of 6 marks and for a grand total of 100 marks. That ends here.
And Dr. Motsamai, thank you very much. From the chat, I don't see any hand. And also, I don't see any written message. And being that, I think we have done well until this point. And I would like just to make 2 comments, and then maybe we'll let people go and do the other work. First one, that it is to apologize to the colleagues that the marking guideline is not having an Afrikaans version. in the guideline. We'll look into that at least where we iron it out. There should be an Afrikaans part in any marking guideline. So we'll look into that. And also for the colleagues who help us in setting this paper, job well done. And we appreciate everything and every effort that you are putting in. And also to you, Motsamai, for being so handy in helping us with this memo discussion. So the floor is open to each and every one of us colleagues that we will be asking you to come in and help us with the memo discussions. Also, colleagues, for the setting, I think we see we are rotating. It is part and parcel of the teacher development that is expected of us, that we should be there with what we are doing at the school level. And then from all of us, we want to thank you very much for the effort that you are putting in. And Marlene, your point of duplicating your question for the multiple choice and 5.1, point well taken, and then we'll take care of it. And any other colleagues, don't hesitate. If you see that there was something, an oversight on our side, we are just human also. We'll accept where we have made mistakes, and then where we have done well also, we'll give you a pat in the back of our shoulders. And colleagues, this is the second last, I think, memo discussion for the year. Let's join for paper 2 tomorrow. And yeah, we'll see how far we'll go. Best of luck in everything, colleagues. Any word from you, Tate, Motsamai, and other colleagues, if you do have any before I close the meeting?
No, I'm good, Ntatensia. Thank you very much for the opportunity, and also thank you to the colleagues who assisted with contributing towards ensuring that we have a working memo guide, marking guideline. Contributions are welcomed, very much welcome. Please don't hesitate to provide your options as well. Thank you to the colleagues for taking care of me as well. I had a good time. Thank you, Minia.
Thank you, Ntate Motsamai. Any other colleagues? Okay. In the absence of any colleagues, let's enjoy the day. May the good Lord be with us throughout. Thank you very much.